Hi everyone, today we are going to solve a very simple but yet a bit complicated because of the wording of this problem. First, let's look into the question. The question asks to find the ratio of the number of their molecules. So first, what we need to understand is the equation that we are going to use for this problem. So the equation we are going to use is none other than for moles, which we know is moles equals to weight divided by molecular weight. And this is mainly what we are going to use, okay? So I hope you know how to use this. So if you don't, a very simple way to understand is that whatever weight is given, okay, for the atom or the molecule, and then you just have to divide it with the molecular weight. So for example, if I talk about 6 grams of oxygen, so you will put 6 here and the molecular weight of oxygen. Okay, now let's look into this question. The question is saying that the ratio of masses of oxygen and nitrogen in a particular gaseous mixture is 1:4. So let's imagine that this is a container and it has a load of gases. And let's imagine there is oxygen and there is nitrogen and there are more gases. But however, we are going to consider only oxygen and nitrogen since that's what the problem asks. So we see that the ratio of the masses of oxygen and nitrogen is 1:4. So what this means is that if there is 1 oxygen, there should be 4 of nitrogen. That's basically what it means. Now, we are going to use this equation as I have said before, and what it's saying is find the ratio of number of their molecule. So when we see this word molecule, what is essentially is talking about the molecular weight. So we have to take into consideration of the molecular weight of oxygen and nitrogen. How can we do that? Okay, let's just put in the ratio. Since we are talking about ratios, and we know whenever we are talking about ratios, it basically means something divided by something. So let's say N1 divided by N2. Now, let's say N1 is oxygen and N2 is nitrogen. And now let's put, so for the molecule, for the moles of oxygen, what is this going to be? Let's say this is weight 1 divided by molecular weight of 1. And as I have said, 1 refers to, let me put it here. Okay, so this refers to the oxygen divided by weight 2 divided by molecular weight 2. Now when you rearrange them, but essentially it comes as weight 1 divided by weight 2. Let's put a bracket here into molecular weight 2 divided by molecular weight 1. Now hold on. We know this, right? Because it's given. The ratio is given, so we can directly put them in. So 1 divided by 4, right? Because as I have said that the ratio of masses of oxygen and nitrogen in a gaseous mixture is 1:4. And now, let's say, do we know this? Well, of course we do. The molecular weight of nitrogen, it's it's 28. It's 28, right? Because 1 nitrogen is 14, so 2 nitrogen is going to be 28. And the molecular weight of oxygen, this is going to be 32. Now, when you do that, the answer comes 7 divided by 32. And this is the answer.